Hello, welcome back once again. Today we have this interesting and amazing topic, integration by parts. I know you must have heard of this, right? It is really amazing and elegant way of solving some indefinite integrals. Are you with me? Okay, so in this video I'm going to explain and derive the formula for this integration by parts. We know sometimes we may need to integrate a product where either function is not the derivative of the other. Did you get it? For instance, let's say we have the integral of x squared multiplied by the natural log of x dx, right? So you can see clearly that the natural log of x is not the derivative of x squared, neither is x squared the derivative of the natural log of x. Did you get it? Therefore, it necessitates that we find another method of obtaining such integral. Say we have u and v. Say we have u and v functions of x. Say we have u and v different. Say these are two different functions of x. You understand? Say u and v are two different functions of x. Okay. Functions of x. Okay. Then we know from the product rule. Did I get it right? Yes. So we know from the product rule that their derivative, the derivative of their product uv is equal to u multiplied by dv dx, right? Then plus v multiplied by du dx. Hope we are making progress. Okay, so what is next? Let us integrate both sides of this equation with respect to x. We know the left hand side, if you integrate, that should be the reverse order, right? So it will give us uv, then this will be equal to the integral of u times dv dx with respect to x, so there will be a dx, right? So plus, here we get the integral of v multiplied by du dx, then with respect to x. Are you with me? Okay, so can you figure out what is going on? Something really cool, right? So there are some nice cancellations going on, this and this, this and this. So now you get uv is equal to the integral of u dv plus the integral of v du. And for the sake of convenience, we can write this as the integral of u dv is equal to uv minus the integral of v du. And we have our formula for the integration by parts. Did you get it? Okay, now let's tackle one problem. So let's say we have our example 1. So our first example, we're going to integrate x squared multiplied by the natural log of x dx. Okay, so now let's set our u equals the natural log of x, and we know very well that the derivative of the natural log of x is just 1 over x, and here we have our dx. Then what is our v? Good question. Our v is the integral of the other function, which is x squared left, right? Dx. So we know the integral of x squared will give us x to the power of 2 plus 1, which is 3, divided by the new exponent 3, right? And take note, this right over here is this. Okay, don't mistake it for this. It's not more x squared. Okay, then differentiate, so you know its derivative must give us x squared. Did I get it right? Yes, of course, that should be the reverse order. Okay, so from here, our integral, remember from the formula we get uv, our uv here is natural log of x multiplied by x cubed divided by 3, right? Then minus the integral of v. What is our v? Our v is x cubed over 3. Then du, our du is 1 over x, and here we have our dx. Are you with me? Let's keep going. Okay, so here we get x cubed over 3 multiplied by the natural log of x, right? Then minus, we can write this as 1 over 3. Then the integral, we know from here, we know we have x cubed over x, which is just x squared. So here we are integrating x squared and we have our dx. Use this power rule. The integral of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus c. So use that there. So you can see we get from here x cubed divided by 3 multiplied by the natural log of x, and here minus, so this is going to give us, I think that will be 1 over 3 multiplied by, so the integral of x squared will give us x cubed over 3 then plus c. So simplifying nicely, we get x cubed over 3 multiplied by the natural log of x minus 1 over 9, right? Okay, multiplied by x cubed, then plus c, and here we have the solution. Okay, now let's talk about more integrals that may seem difficult to integrate. So say we are going to integrate x times sine of x. So our example 2. So let's say we have to integrate x multiplied by the sine function of x dx. So here our u is going to look nice, right? So let's u equals x, that is this function here. So our du is equal to 1 times the x, which is just dx. So our v, do not forget that v is always the integral of the other function, which is the sine of x. And the integral of the sine of x gives negative cosine of x. Okay, so our u, always circle it just to remember for the sake of convenience, right? So this is our v. Therefore the v will be, the derivative of the cosine of x will give us negative sine of x, and with that negative sign it turns out to be positive sine of x. Interesting, right? So our integral now is going to be, remember uv, what is our u? Our u is x, and what is our v? Our v is negative cosine of x. So this will be negative x multiplied by the cosine of x, right? Yes. Okay, minus the integral of v is negative cosine of x du, which is just dx. So this is going to be equal to negative x times the cosine of x, that will be plus the integral of cosine of x dx. Okay, so this is going to be equal to negative x times the cosine of x, then plus, so the integral of cosine of x, that will give us sine of x. So we get here sine of x, and we have our plus c, which is the constant. So this right over here is our solution. So you can see that the integration by part is an elegant way of solving indefinite integrals. Okay, so what is next? The third example is going to be, oh god, so this one is going to be more difficult. Okay, so our third example, example 3. So let's integrate e to the power of 2x multiplied by the cosine of 3x, and then we have our dx. So say our u is equal to the cosine of, oh sorry, that is 3x, not x, pardon me. Okay, so let's say cosine of 3x, and you know how to differentiate. We know the derivative of the inner function will give us 3. Is that not 3? That is 3, right? Okay, so the derivative of the inner function is 3, but the derivative of the cosine of x will give us negative sine of x. So this will give us negative 3 multiplied by the sine function of 3x. Then our v is going to be the integral of the other function e raised to the power of 2x dx, which we know very well that this is going to give us e raised to the power of 2x divided by 2. So circle it. This is our v. Okay, so the v is going to be just the function itself. Okay, so what is going on? So this integral, let's call it I. Yes, cool. So our I is going to be uv. uv is e raised to the power of 2x over 2. Hope I'm making sense. Yes. Then multiply by the cosine of 3x, then minus the integral of v, which is e raised to the power of 2x over 2 du, negative 3 the sine function of 3x dx. Integration by parts again. So but let's rewrite this properly. So I is equal to 1 over 2 e raised to the power of 2x times the cosine of 3x minus, this should be plus 3 over 2 times the integral of e to the power of 2x multiplied by sine of 3x, and then we have our dx. Okay, so the next, work on this with the integration by parts. So we set u equals the sine of 3x. So du, the derivative of the inner function, which is 3x, will be 3 multiplied by the cosine of 3x. So this is the derivative, and our v is equal to the integral of e raised to the power of 2x dx, which is just e raised to the power of 2x divided by 2. Our dv is going to be the function itself, e to the power of 2x dx. Okay, so from here we get I, already we know 1 over 2 e raised to the power of 2x times the cosine of 3x, right? So cosine of 3x plus, so this right over here, 3 over 2, opening a bigger bracket. So uv here is 1 over 2 e to the power of 2x multiplied by the sine of 3x minus the integral of v. v is e raised to the power of 2x over 2 du multiplied by 3 cosine of 3x dx. No space, but pardon me. Okay, so from here, open that bracket properly. Something nice is cooking, right? So this is 2x here, cosine of 3x, and here plus, this will give us 3 all over 4 e to the power of 2x times the sine of 3x. Then this will be minus, that should be 9 over 4, because we have 3 over 2 right over here, and we have the integral of e raised to the power of 2x times the cosine of 3x dx. Did you find out something? This here is our I. If you check it out, you will see that that was the first integral we started with. Okay, so we get I is equal to 1 over 2 e raised to the power of 2x times the cosine of 3x plus 3 over 4 e raised to the power of 2x times the sine of 3x. So 9 over 4 times I will give us 9i over 4. So add 9i over 4 to both sides. You'll quickly get 13i over 4 is equal to 1 over 2 e to the power of 2x. No more time like that. Okay, so cosine of 3x plus 3 over 4 e raised to the power of 2x times the sine of 3x. So multiply both sides by 4 over 13. So the left hand side will turn out to be I, which is our main integral, and we get 2 over 13, right? If you multiply 1 over 2 by 4 over 13, that will give us 2 over 13, and then we have e raised to the power of 2x multiply by cosine of 3x, then plus multiply this by 4 over 13, we get 3 over 13. E raised to the power of 2x multiply by the sine of 3x, and then plus c. So this is our solution. Thank you for watching. Please to support my channel, and if you know you like this video, please comment. Next video will be uploaded very soon, but please support by subscribing. Okay, thank you for watching. Make sure you subscribe and please turn on the notification button so that you'll be notified whenever I upload next amazing video.